Why lean construction? In this video, we will look at the benefits of taking a lean approach to project delivery. We will answer the question, what is lean project delivery? We will explore how lean projects are organized, some of the methods and approaches that enable a lean approach, and we will briefly review what is different about lean projects from a contractual point of view. A question that may seem obvious is, what do owners want on projects? First of all, lower cost. Most owners feel they should be getting better value for their money. So is it possible to improve efficiencies and eliminate those activities that drive up costs? Secondly, better schedules. Many of the things that drive up costs can also create schedule delays. So does a lean approach improve schedules without resorting to inefficient fast-track scheduling? Finally, better quality. Owners pay for value. Owners don't want to pay for over-designed facilities, rework, change orders to correct defects, or to finance follow-on projects to get what they wanted in the first place. So does a lean approach deliver a better product and a higher satisfaction to clients and customers? Traditionally, it has been said you can get 2 out of the 3, and you need to choose which ones you want. Yet, how is it that those firms who have adopted the lean approach are delivering on all 3? Plus, for those on projects, how can lean improve the team environment? Our interviews with team members on lean projects said they didn't want to go back to the old traditional approach. So we will look at how a lean team is developed. For those of us who facilitate operational excellence training, we like to show this next statement. We will have to do things quite differently if we are to see the improvements we are looking for on projects. So why do we need a different approach? This chart tracks the percentage of labor productivity gain over the last few decades. The blue line is manufacturing. The line we should be concerned with is the red line. Construction has essentially flatlined, even with the introduction of CAD and other technologies. The pie charts below illustrate the level of waste in relation to value to the customer. Manufacturing has increased labor productivity to deliver well over half in value added to the customer per labor dollar spent. Construction, not so much. In other words, for every labor dollar spent, roughly 10% ends up being of true value to the customer. The rest is non-value. So where does lean come in? Lean targets the waste that adds costs, drags out schedules, and compromises quality. Lean brings philosophies and methodologies that enable improvement and innovation from project teams. So what is lean? The term lean was coined by a contingent of visiting American researchers who observed the Toyota process for building cars. Lean project delivery is a production approach applied to construction. The key principles are reduction in waste with maximization of value. However, lean is different from the traditional approach to saving money. Lean project delivery is no more about cost cutting than weight loss is about amputation versus diet and exercise. Each approach may get you to a target weight. One just leaves you a little more functional than the other. Previously, it was stated that lean challenges the generally accepted belief that there is always a trade-off between time, cost, and quality. But I had my own doubts. Even though I personally led a lean transformation for another manufacturing company prior to starting a career in project management, it hadn't dawned on me that lean also works in construction. That changed after I managed a project in Japan. There I experienced a different project culture, one that focused on value and efficiency. Trust and respect was real and not merely an aspiration. The value of team over self-interest translated into a project that finished exactly on the date committed to at the project start and significantly under budget. A few years later, a team of us went to the leaders in industry to do our own research. Our team directly surveyed over $6 billion in installed lean projects and reviewed numerous published case studies. What we found was that lean projects were delivering project cost improvements of 5%, 10%, and even better than their company's previous benchmark performances. This next statement sums up the lean objective. Real value is not the low bid on a high-cost design. It is the low true cost on the right design. So let's take a look at what value is and isn't in construction. Value is defined as what the customer is willing to pay for. Waste is the non-value added cost. The value added part of construction is fairly obvious. It is the erecting steel, pouring mud, framing, and other tangible activities. What is not so obvious is the incidental support activity that in itself does not add value, yet is necessary to support the transformation of raw materials into something the customer values. I was explaining this to one of our PMs who challenged that these also were value-added activities. So I asked, did the customer keep or need the concrete forms? Does the scientist in the building care how many sheets of drawings are produced? The only thing the customer values is what he or she can directly use in their work. It dawned on him that although these activities are needed, they don't directly add value. Any activity in this category is a candidate for removal or streamlining. Then there is pure waste. It's the correction of mistakes, the waiting for security to open the building to let workers in, the rescheduled meetings that result from key participants failing to show. It's the walking around search and rescue effort to find tools and parts, and the shuffling of piles of materials from location to location around the job site. And the owner pays for it all in the form of buried contingencies and built-in productivity factors. So let's do a breakdown on the 7 wastes as they apply to projects. First, there's defects and rework, the scrapping or redoing work that adds cost with no increase in value. This is the rework of drawings and paperwork, the relocating of sprinkler heads after T-bar installation, the extra patch and paint done by others, and the rescheduling of meetings when required people failed to show. Why? Out-of-sequence work, unclear or late information, late decision-making, inaccurate drawings, and poor quality materials. It is interesting to note that studies have also shown that rework is one of the demoralizing factors that lead to decreased productivity and job satisfaction. Overproduction. The building or producing more than what is needed, or producing too early, which could lead to one or more of the other wastes. This can be seen in reports and presentations containing more information than needed or produced too frequently. Unused drawing details. Stockpiles of dusty and dirty unused fabricated assemblies because they were brought on too early, often resulting in scrap. And the unnecessary double or triple redundant systems. Why? Over-design due to undefined requirements from the end user. The just-in-case logic that leads to designing more than needed, resulting in gold plating. It's where the additional dollar spent doesn't result in a real dollar in increased value to the customer. Inventory or queue. The work stacked up too far in advance of when needed or in big batches waiting for use. This may trigger other wastes, such as unnecessary transport or defects from mishandling or contamination. This can be seen by documents such as RFIs, submittals, and POs stacked up waiting for approval and physically in stockpiles of materials or work in process held for long periods. Why? Often because of mistrust. On one job, I asked the mechanical foreman why he had all his ductwork on site instead of having it delivered as needed. He said he wanted control of it. I counted one pallet being moved over 3 times before the material was used. This lack of resource planning ties up money and may result in other wastes such as having to move the stack around or replacement of dirty or dinged material. Overprocessing. The performing more operations or using excessive specifications yielding no additional value. This can be seen in redundant reporting, red tape for onboarding staff, lack of clarity with paperwork, multiple inspection and approval steps, expediting of orders, excessive coordination required between suppliers, use of more expensive material, parts, or labor than what is required. Why? Overcomplicated processes for approval, reporting, and administration. Lack of communication, mistrust resulting in more inspections and quality checks, and improper labor skill distribution. Motion. The extra body movements and searches that do not produce any additional value to the job. This can be seen by the excessive searching for information, the walking from meeting to meeting, multiple trips up and down the ladder to get tools or parts, and poor work area layouts resulting in ergonomic injuries and safety issues. Why? Inefficient folder structures, poorly designed processes, lack of standard work methods, or no pre-planning, poor work area organization, and less than the best housekeeping. This is a spaghetti diagram tracking the movements of a typical worker on the job site. What is obvious is that very little of these movements are in doing actual value-creating work. He's either looking for tools or parts, hauling material to the work area, asking questions, or stopping to figure out what to do next because of inadequate instructions or waiting for his foreman to show up. How often have you heard of the $50 an hour worker having to drive to Home Depot to get a $5 part? Transport. The moving material from one place to another. It's funny why anyone would think drywall increases in value every time you move it. This waste can be seen in the excessive manual routing of documents, multiple moves of stockpiles, and clearing items out of paths of travel or out of areas of work. Why? Lack of process flow, poor site layout, lack of planning by foremen and/or supervisors, and early deliveries adding to the congestion to the site. Waiting. The delay or idle time before a person is able to start the next activity. This is seen by the waiting for approvals, waiting for security to open a door for teams to start work, failure of a team member to show up, meetings not starting on time, missed or shifting deadlines, waiting on instructions, plans, or resources to do assignments. Why? Late decision-making, inadequate coordination, no-shows or late attendees at meetings, broken processes and systems, and the delays created by drawings or RFIs released in large batches instead of in timely, smaller chunks. There is one additional waste: unused human capital. The missed opportunities to create and implement ideas that could have reduced costs or increased value in the process. The symptoms of this waste is low morale, poor participation and collaboration, cynicism, and few innovations. And why is this? Some participants, including the trades and end users, are not included in design and problem solving. Continuous learning is not encouraged, and top-down management styles can hinder team members' empowerment to innovate and make improvements. An example of how this waste was narrowly avoided was told to us while visiting a billion-dollar hospital program. It was their story of how seismic bracing was addressed. Originally, they were planning on using base isolation. However, during design, the team realized the building moving out of phase with the sidewalks created a real safety hazard to pedestrians. In one of the meetings, a junior structural engineer suggested using viscous wall dampers as used in Japan. The senior lead designer neatly blew off the idea because it wasn't a traditional solution. Fortunately, the construction management PM kept the idea alive, which ended up being the only viable solution. The result was a significant savings in steel and concrete costs to the project. This innovative idea could have easily been missed because it didn't come from one of the senior engineers. However, a lean culture promotes inclusiveness and curiosity where all team members have the opportunity to be heard and to contribute. This eighth waste also impacts safety. A project can be exposed to disaster when team member voices are not heard as happened with the 1986 Space Shuttle O-ring incident. Why is waste difficult to see? Busyness. It seems like project team members can be like cars with low tire pressures that are too busy to stop to fill up with air. They are running with their engines redlining, burning up precious fuel in sore need of a tune-up. However, no matter how counterintuitive it feels, a lean approach means going slow to go fast. It means taking the time to stop to make improvements. And then there are those few people who just don't want to put the effort into learning and changing. These types you don't want on your projects. In fact, on several of the projects we visited, we were told of those former team members who would not embrace the lean approach that were voted off the island by other team members because these laggards were hindering adoption of improvements and costing the team and the owner money. I recently spoke at a conference on this very topic of lean project delivery, much of which is what you're watching now. And the question usually arises, will lean work in pharma construction? Some of the arguments I hear are, we're not Toyota. This was the argument 20 years ago in manufacturing. But today, just about every company that has stayed in business has embraced lean and Six Sigma to stay competitive. We're not manufacturing. This was the argument hospitals were giving 10 years ago until the cost of health care forced many of them to adopt a lean approach to construction, such as Sutter Health and Universal Health Services have. We're not hospitals. Other sectors, such as public schools, community college districts, and major theme parks have made lean the preferred approach to constructing and improving their facilities. We're not, well, you can fill in the blank. Needless to say, there is a tremendous amount of waste in how pharma facilities are built and renovated. The opportunity for savings is ripe for those who will take it.
All right, I'll give it a try.
No, try not. Do or do not. There is no try.
During our research, I talked with a few teams that tried to do lean but failed. A lean approach takes commitment because it is disruptive to the status quo and difficult to undertake. Nevertheless, as in any meaningful, significant change, lean is well worth the effort. Lean construction approaches the creation of value and the elimination of waste from three sides. Organizationally, how teams work. At the operating system level, the methods and tools. And commercial terms, how contracts are structured to support lean behavior and capture savings. We'll start with the organization. This part of lean is called Integrated Project Delivery, or IPD. Projects are about people and how people are organized to transform ideas into something concrete. So let's start with the project. There is the proposed idea that gets further designed and refined with further input, then constructed slightly different from design. Then there is the fine-tuning after turnover. But this is what the end user wanted. Now this is all tongue-in-cheek fun. Nevertheless, how often do projects fail to truly satisfy the end user? Project team members should start out with a shared understanding of their objective. But sometimes things don't always work out as planned. Why? Because information is often missed in the handoff between team members. Now for a typical project arrangement. We start with the owner, designer, and constructor, but is more complex than that. The owner has equipment suppliers and consultants. The designer has their own consultants and engineers. And the constructor has a multitude of contractors, trades, and subtrades. So if the end user has a specific need, say a suite needing a controlled environment of temperature, humidity, and airflow, the trade contractor who will meet the need is here. And this is the information path to get from the end user to the trade. This is kind of like the rumor game we played as children, where one classmate whispers a story in the ear of another, who whispers what was heard to the next child, so that by the time the story is repeated around the class, it is only vaguely familiar to the original story. So how do we improve information flow? Let's start by looking at how projects bring on team members. Obviously, it is not until a member joins the team that they will have an understanding of what to do. A traditional project looks something like this. First, the owner brings on the designer, then some engineering, then the CM, and finally, at execution, the trades who will actually construct the facility. This curve shows the level of shared understanding by the entire team as the project progresses. Because it is not possible for trades to get a complete understanding during the very short bidding process, a rash of RFIs and change orders are soon to follow. All too often, because of the time lost getting the full team on board, we have to bring out the money cannon to meet the now fast-track schedule. The integrated project delivery approach brings on key players earlier in design and keeps them on through completion as needed. Trade detailers and trade engineers take on more of the design load. This brings them closer to the end user, who is also engaged more fully up front. Lean projects begin with a soft start, which is more than just a team builder. A soft start involves all the major players to develop what is called the conditions of satisfaction. This resulting statement clearly lists out what success looks like for the project to ensure alignment and as a compass for true north understood by all on the team. The benefit of IPD is an earlier shared understanding to deliver the right design with less waste. Another way of looking at the benefit of early team involvement is the front-end loading effect. Right decisions made early are far less costly than those made in the later phases of the project. A traditional team of decision makers ramps up like this. The IPD approach brings decision makers and influencers, which includes those from the trades doing the execution, on much earlier. Man-hours are front-loaded. Nevertheless, the total hours will be overall less than the traditional approach. The concern some people have for early onboarding trades is that it will cost more because we as the owner lose our leverage of getting a competitive bid. However, experience has shown that when trades are selected on a best value basis to participate in early design, we get a better design, fewer costly design decisions late in the project, and a better project outcome, including an overall lower cost. Again, let's look at a typical project team. We start with the owner, designer, and constructor. On equipment-intensive projects, we may also include the OEM supplier as well. The IPD approach brings these members together as a core team. Then we include the trades and engineers. On larger projects, a big room is used to co-locate team members to increase effectiveness and information sharing. Also, contracts are drafted to minimize conflicts and remove barriers to collaboration, which we will look at in a few moments in the commercial terms section. It cannot be overly emphasized the importance of having the right team. Without the right team members, it doesn't matter what methods or contract structure is used. My experience managing a project in Japan opened my eyes to what a collaborative team culture looks like to make lean work. Allow me a moment to digress further on this line of thought. The Western reductionist mindset, which I was prey to, would view teams as merely the sum of each of its parts. In a lean environment, the team objective is more important than individual agendas. A team is alive and organic, much like the human body. It is composed of interdependent parts or subsystems. It is a whole system. Sure, a body can be reduced to component parts, yet each of these subsystems contains no life unless completely integrated with the others. You can remove the parts from the body and dissect them. You can describe each of these systems independently, but they are dead. Their life depends on their interdependence. Unify the parts and a magical thing happens. It gains life as the parts interact and support one another. Only when the body is whole can we say that it is a human life. The whole is truly greater than its parts. The time spent on developing and fostering a healthy team environment is one of the best investments a project can make to eliminate the waste created from misunderstanding and misalignment. In summary, for the organization side of the Lean Triangle, Lean teams are different. The team structure breaks down the silos so that the work is aligned toward a common goal. The focus is on maximizing the project instead of protecting self-interests. Leadership moves from being top-down, command and control, to one of collaboration and listening. Commitments move from being purely transactional to being relational, where team members help one another in achieving a common goal of project success. Learning becomes a goal, and failures are used as learning opportunities for continuous improvement. A no-blame culture makes this possible. An integrated team in a culture of trust is foundational to a positive project outcome. Without an integrated team, as stated earlier, the rest of the Lean methods and contracting will be only marginally successful.